Most of the time, if we pay attention to clouds at all, it's because of their effect on our local weather. Or maybe it's because they make a sunset prettier. But what you might not know is that clouds affect us every day, even if we're staring at a clear blue sky. The clouds we see when we look out the window are important components of a complex global weather system. They play a key role in Earth's water cycle, carrying huge amounts of fresh water and dropping it as precipitation. And depending on their properties and where and when they form, clouds can have dramatic effects on our climate, influencing the locations and severity of floods and droughts, and even the temperature of our planet as a whole. So by understanding clouds, we can better predict severe storms, the global distribution of fresh water, and the course of climate change. But what exactly are clouds, and how do they form? All clouds share the same basic ingredient: water. They're made up of water droplets or ice crystals that have formed from water vapor in the atmosphere. Although you can't see it or feel it, the air around us contains water even on the clearest summer day. The main sources of this vapor are evaporation, which is the escape of water molecules from the surface of oceans, lakes, and soil, and transpiration, the release of water by plants. As the sun warms Earth's surface, heat is transferred into the atmosphere along with water vapor. The warmer the air, the more moisture it can hold. But warm air doesn't usually stay near the surface for long. Like a hot air balloon, it rises. As it does, it cools. The colder the air becomes, the less water vapor it's able to hold. If the air becomes cold enough, it reaches a state called supersaturation, which causes some of the water vapor to transition back to a liquid or solid state. Water molecules in the vapor form around tiny particles of dust, ice, sea salt, and pollution suspended in the atmosphere. These particles, called condensation nuclei, serve as the starting point for the formation of water droplets and ice crystals. With this final step repeated billions and billions of times, the water that's been in the atmosphere all along is suddenly visible. And a cloud is born. While we can now see the cloud, the individual droplets or ice crystals are tiny, which is why they remain airborne. But they can combine to form larger drops or crystals. And if they become large enough and too heavy to stay aloft, they'll fall as rain, snow, sleet, or hail back to Earth's surface, where the water in them came from originally.